Hello students, today we're going to be talking about percent application, finding the part. So this is proportion problems using percentages and finding the part. Now we've talked quite a bit about proportion, so this is just kind of a continuation and review of proportionality problems. At the top of your notes page, it says percents can be helpful in solving real-world problems. Consider thinking through the questions below to help you organize the information and set up a proportion. So it's important to ask ourselves, what information are we given? What are you solving for? So typically what you're solving for is going to be whatever information you're not given. And is that represented by the part, the whole, or the percent? And then finally, does your solution make sense in the context of the actual problem? So determine what information you have, whether or not it is your part, your percent, or your total. Whatever is not present in your problem is what you're solving for. And then ask yourself if it makes sense in that context. So the scenario that they give us for our notes today is, at Paulson Middle School, 75% of the 6th grade class is making a B or higher. Okay, so let's go ahead and change that to TVMS Middle School. So at TVMS, at our middle school here, 75% of the 6th graders in total are making a B or higher. That would be amazing if everyone is making a 75% or higher. If there are 24 students in the 6th grade class, then how many are making a B or higher? So let's go ahead and break down what we know first for question A, the information that we know. We know our percent, right? 75% of the 6th grade class is making a B or higher. So our percent is 75%. We know that. We also know our whole. We know that there are 24 kids, 24 students, which is equal to our whole in the 6th grade class. Now the information that we need to know is how many are making a B or higher. Many, how many is going to be your part. That's what we're looking for. We need to know the part, question mark. Okay. Are we looking for the part, the whole, or the percent? Well, we know it's the part because it's saying how many students are making a B or higher. So we're looking for the part. And then it says sketch a diagram, a tape diagram to represent the situation. Okay, so I know that 0 students to 24 would be 0% to 100%. If I have no students, then I have 0% of my students. But if I have 24 students, then I have 100% of them. So I know that 75% of the 6th grade class is making a B or higher. 75% is 3/4. 75% is equal to 3/4. Okay, so I know that half of 100% is 50%. I know that halfway between 0% and 50% is 25%. That's 1/4. And I know halfway between 50% and 100% is 75%. So if 75% of the students are making a B or higher, then we can shade all the way up to 75%. Okay, now we need to find the numerical values of these numbers here. If I was to take 24 and break it into 4 equal parts, 1, 2, 3, 4, which is what I did with my percentages, what would each percentage or what would each quarter come out to or be worth, really? So 24 divided into 4 equal groups would make each portion equal to 6. 6. Halfway would be 12. Half of 24 is 12. And then a third or 3/4 of the way would be 18. Because 6 times 3 is 18. So I'm just going to go back and erase these right here. So it's not super important that you have that. I just wanted to show you that your bar was being cut into 4 equal parts. So now, what is the solution, and does the solution make sense in the context of the problem? Okay, so we're saying that 75% would be equal to 18 students. Now I know that this makes sense because in my bar diagram, I took my 0 students to 24 students, and I know that 75% is equal to 3/4. So I broke my percent bar up into 4 equal parts, 75% being 3 of the 4 parts. And so if I split my percentages up into 4 equal parts, then I have to split my total, my 24 students, up into 4 equal groups. And 24 divided by 4 is 6, making 6 students at each quarter of the way. Okay? And so 3/4 of 24 would end up being 18 students, because 1/4 of 24 is 6, half of 24 is 12, and 3/4 of 24 is 18. Therefore, this does in fact make sense in the context of the problem. Now let's go ahead and do problem number 1 together, and then I'm going to have you do problem number 2 by yourself. So a campus survey states that 40% of the students ride the bus. If there are 300 students, then how many would ride our bus? So let's look at your problem here, right? I know what information I have. I have my percentage, and I also know my whole, my 300 students who are on campus, okay? So that means that my 0% to 100% would be my 0 students to 300 students, because 300 is my total, my 100, okay? And the campus survey states that 40%, of the students ride the bus. So what we could do is we could split this bar equally into tens. So that would make this 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. 10 equal groups, okay? So therefore, if I'm splitting my 100% into 10 equal groups, then each section will be worth 10%. So I know that the campus survey states that 40% of the students ride the bus. So if this is worth 10%, this would be worth 40%, or 20%, excuse me. This would be worth 30%, and this is where my 40% would lie. 40%, okay? So if each of these little sections here is worth 10%, then that means I also need to split my 300 into 10 equal groups. So 300 divided by 10 is 30. 10 goes into 30 3 times, which is 30. Nothing left over, drop your 0, okay? So that means that each of these is worth 30. This is 30. That would make this 60. That would make this 90. And that would make this 120. So that means that 40% of 300 is 120. Okay? And I know that that's right, because if I was to set up a proportion table like we're used to, your part to whole relationship would be your 40%, which is 40 over 100. Your total amount of students is 300 students, so your scale factor is times 3. So therefore 40 times 3 is 120. Okay, and I know that that's reasonable. So what I want y'all to do is solve question number 2 on your own to the best of your abilities. Good luck to you.